Okay, today we are going to write a program for finding maximum subarray sum. Maximum subarray sum. We will use an algorithm known as Kadane's algorithm. Okay, so before that, let me explain the problem. Assume you have an array containing integers like 1, -5, 3, 2, -6, 7, 8, 9, -9. Okay, so what is the maximum sum of any subarray? Subarray can be a single element. You can have 1, 2, 3, 4, 5, 6, 7, 8 single subarray, right? Subarray containing only one element, or you can have two element. It should be continuous. Okay, it should be adjacent elements. You can't have a subarray from one element from here, another from here, without including the middle elements. So subarray with the two elements is this one, then this one, then this one, like that. Okay, so this one, so subarray with the four elements. Okay, so you need to find out which subarray contain the maximum sum. So here, by looking at the you can say that one, if you don't need to include this one, because whenever you are adding this -9, obviously the value will go down, so it's better not to include. So consider this one only, right? Like that. Or you can see here, 1 is a positive, and obviously it will increase, but if you want to include 1, you need to include -5 also, right? Obviously. So what will happen? -5 plus 1, -4. So same way, -9, if you are including to that array, it is going down. Same way, obviously we have a lot of positive number, that's why it is you can say that if you are adding a negative number in the side, it will reduce the sum. If everything is negative in this array, that's a different case. Okay, in this case actually, -4 it's adding is a waste, and here -9 also adding a waste. So you need to focus on up to this point. Okay, here 3 is a positive, 2 is a positive, -6 is a negative. So if you are considering these three, you can see that one, it's a -1. Sum of these three are a -1. So it's a actually adding that to sum, it will reduce the value. So 7 plus 8 is a 15. That's a maximum sum. So yeah, it is depend, since it contains both positive and negative. You can do some heuristic like this, and you can find out. Obviously, if it is a small array, you can do. Otherwise, if it is a very complicated array, it is not easy to figure out like this. Okay, so there are various ways to solve this problem. You can go ahead with brute force, like finding each subarray, subarray with one item, subarray with two items, subarray with three items. Obviously these subarrays are continuous elements. You should include continuous elements. So then find out the sum of each subarray, and find which one is the maximum, which subarray give maximum value. That's a maximum subarray sum. Okay. Okay, so we need to know that what's a Kadane's algorithm do here. What Kadane's algorithm, the working of Kadane's algorithms like this. It will start from here. It will consider as a current sum is 1. Okay, then it will basically it is going through each element one by one. First it will start from here 1, then it will consider second, then it will consider third, like that. Okay, so first it will consider this one and add as a start at the current sum is 1. Okay, then second element, if you are adding the second element, you need to decide whether we need to include both or we should consider this itself. Okay, how you can decide that one? So assume that one is a -5, and by adding previous sum is 1, it's a -4. Obviously you need to track -4, right? Not this element itself, a sum of these two elements. Okay, now we keep a current sum, it is a -4. Okay, then we want to consider this element. So you can see two scenarios. One is if you starting from here itself, the value is 3, and if you are considering the previous value also plus this value, then what is we have one we are keeping track of a current sum. Okay, so we know that's -4, and -4 plus 3 is 1, and this element itself 3, whether we want to 1 or 3. Obviously we want to 3, that's a maximum subarray, right? So we will discard the current sum and add this to as a current sum. Here we what we have done is that we add to the previous current sum 1 plus -5, that became the current sum, right? In this case we checking if what will happen if we add to the current sum. Current sum is a -4 here and plus 3, then new current sum can be 1, or you can ignore the previous things and start from here, then 3. So obviously we will go with the 3, then we will add with the current sum is 3, then we will consider this one. Okay, so here there are two possibilities. You can add with the current sum 3 plus 2 5, or you can ignore the current sum and start from here, it's a 2. If you are adding the previous current sum, it will be 5, so we will add with that one. Then we will consider this one. Here what will happen, current sum is 5. If you are adding value will be -1. If you are adding to current sum, new current sum will be -1. If you are not adding, you are starting from here itself, it will be -6. Obviously -1 is bigger than -6, right? So we will add. So this it is the current sum now, it's a -1. Okay, then you reaching here, so you will check adding 7 to current sum is -1. -1 plus 7 is 6, or you can start from here itself, that's 7. Okay, whether we want to add to previous sum, or you should start from here itself. Obviously you will start from here, so you got 7. Then you need to consider whether you need to add 8 to the current sum to get the new current sum, or start from here. The question is that whether you want to 15 or 8. Obviously you want 15, so you will connect this one. So now here you reached it's a -9. If you are adding, it will reduce the value. Okay. Okay, obviously now what will happen is that if you are going forward, you need to add anyway, right? -9 15, that is 6, or -9. Okay, current sum obviously now 6. Okay, current sum is obviously x. So every time you need to know that current sum is going through, first it was 1, then it became, by adding this one it became -4, then it became 3, then it became 5, right? So the value going up down. Okay, so you need to keep track one more variable, that is tracking the best sum. So here best sum was 5, right? At this point best sum is current sum is -1, but best sum is 5. So at this point best sum is 7, this point best sum is 15, this point best sum is 15, but current sum is 6, like that. So we need to keep track of two variables. One is a current sum and another is a best sum. Okay, anyway, let us write this code. Okay, first I need to write a variable maximum sub array sum. Okay, so it will accept an array of numbers, numbers, not numbers. Okay, what is this? How it came like this? I don't know. I will prepare an array here itself. Okay, and test data, I will add its test data. Okay, and here I will call maximum subarray sum test data. I will print that one here. It will print the maximum sum. We know that this is the maximum subarray, so it will produce a sum of 15. So what we need to do is we need to go by one by one numbers, right? Let us write a loop for n in numbers. Okay, so okay, we want to define two variable, current sum, which is equal to current sum. Actually let us do one thing. We can consider the first value as a current sum, right? We can do one thing. We can current sum. Let's do one thing. We can write to one lowest value. I'm importing sys dot maximum size. Okay, lowest value I gave as a current sum. Obviously that will be discarded initially itself. So what the current sum is doing is maximum of, we want to take a maximum, right? X here is in n current sum plus n. Okay, so what we are doing is that one this value or current sum plus this value 1. Obviously current sum is a very low number, so we will take n. So first number become current sum. Okay, next we want to another variable, that is best sum. Best sum, what should be the best sum we need to add? Let us add the same thing, very low value, so that it won't be used. Okay, here what we need to do, that best sum, we need to maximum of best sum or current sum. We saw here, right? Here current sum is -1, best sum is 5. Okay, so if you adding this one, current sum becomes 7 and best sum become 7, right? So the same way, what we are doing, every time we are checking, that's a current best sum and current sum, which one is a maximum, then that became the best sum. So that if there is any basically what we are doing is that we are adding one by one here, and we are going like this, adding this one, then if we are adding up to this point, we know that the value will be low, so we will start from here. So current sum like that will change. So we are checking whether every time whether current sum is maximum bigger than best sum, then change the best sum value to current sum, otherwise the best sum itself will be assigned here. Okay, the same way current sum, we are checking whether we need to start from that point, or we need to consider this also. That's what we are doing. If we considering the current sum with the current number, whether that value is bigger than the current number itself, then only we will consider current sum. Like for example here, current sum is -4. When we adding up to this point, this value is -1. Okay, but the value single value itself 3. So we will assign that value as a current sum. So 3 become current sum. Like that we are considering current sum. Okay, and we will apply the best sum also. Okay, yeah, that's all algorithm here we are doing. Then return the best sum. Okay, let me run 15. We got this 15, right? This 15 we got. So what we need to do now, let us change this value to 11. Then what will happen is that if we want to use 11 up to this point, this should not be, it should be less than 11, right? Let's see, -5 and -6 is -11. 5 we got here, that's why extra 5 we got, that's why this will be added. If this value is less than this 5, then it won't be added. Let us check that one. I will add a 5 here, then it won't be added because no, what is the value, total value 5. Okay, it won't be added here. Yeah, 15 only. This is, if I increase this one to 6, oh 6, this will go strike, it becomes 0, and -6 and -6 becomes 0. So if I am adding the 7, it will be added. It becomes 16. Then they are adding up to this point. Okay, like that. Okay, so basically what we are doing is that one, we are keeping two variable. One is a current sum and second is a best sum. We are adding like this, one by one we are adding, and we deciding whether we need to start from the here itself, or we need to consider previous also, based on this one, maximum of that value, comma current sum with plus n plus that value, current element. Okay, so yeah, here we will track current sum is a best sum or not. So this is the main point we are doing, whether we need to, I will add back to 150. Okay, so here is the value, current sum is 1, best sum is 1. Okay, let me print that also, so that it will be easier to understand. Print current best, let me write n also, n format in current best. Okay, I will print this one. So here you can see that one. First we are starting from here, and the value is 1, and current value is also 1, and best also 1. Now second you are considering this one. Okay, if you are adding with this one, current become -4. Okay, so there are two possibilities. You can add with the previous current value. Previous current value is 1 up to this point actually. Okay, you can choose -4 or -5. Obviously we know that -5 is a -4 is a bigger term than -5. So we will add these two things, and it became current -4 become current sum. Okay, -4 current sum, but best so far we got is 1. Okay, then we will try we'll add this element. So current sum is -4. That is representing these two elements. Okay, so if you are adding this one, current sum become 1, sorry, -1. Okay, otherwise if you are not adding to previous, from starting subarray from here itself, it will be 3. So whether we want to up to this subarray or this subarray, that's a question. So obviously we know that 3 is bigger than -1. So current become 3, and earlier best sum was 1. Now we got the 3, right? So it became best sum. So you can see the current is 3 and best is 3. Then we are going to add 2. Okay, we know that when current sum is this one. So if you are adding current with current sum, current element with current sum, it became 5. If you are not adding to previous, starting from here itself, it is a 2. Obviously we know that when adding is giving more bigger number, right? So current sum is 5, and we know that one best sum was 3. Now this current sum became the best sum. You can see both are 5. Okay, like that you will add. Okay, so from this chart you can see that one current best, it is this one. 7 and 8, if you are adding these 7 and 8 are adding, you are getting the best sum. Okay, that will print. Hope this explanation was helpful for you.